In Chapter 10, we're going to explore the relationship between numerical variables. And in our first section, section 10.1, we're going to learn how to display those numerical variables by using scatter plots. A scatter plot is simply a graph that displays the relationship between two numerical variables. Now, in the past, we've looked at the relationship between two categorical variables. And when we examined that relationship, we typically made like a segmented bar graph. But when our data is numerical, that's not an appropriate type of graph to make. So we're going to use a scatter plot. Now, when you make a scatter plot, the explanatory variable is plotted on the x-axis, and the response variable is plotted on the y-axis. Typically, the response variable is the one that we are more interested in, either because we want to make some predictions about that variable or we want to explain changes in that variable. So typically, we might have some control over the explanatory variable, and we can change it in one way or another to see what type of response it causes in the other variable. Now, we say that two variables have an association if specific values of one variable tend to occur in common with specific values of the other. And when we describe the association between two variables, there are three things that we should consider. Number one, we want to consider the direction of the relationship. And this will tell us how the response variable changes, either increasing or decreasing as the explanatory variable changes. Number two, we want to discuss the form of the association. And the form typically refers to the shape. And number three, we want to talk about the strength. And this allows us to be either fairly certain or very certain about predictions that we make from the relationship that we establish between those variables. For the first example, it says in recent years, professional golfers have been driving the ball farther than ever before. Some of this is because of improvements in both the club and the golf ball, but some of the credit goes to the golfers themselves. However, this extra distance can come at a price. As anyone who has ever played golf can attest, trying to hit the golf ball farther off the tee can often result in less accuracy and a more difficult second shot. So, what we're going to look at here is whether golfers are better off trying to hit the ball very far, but risk not landing in the fairway, in other words, having less accuracy, or would they be better off to ease up a bit and make sure they hit the ball down the middle, even though it won't go as far? So, what we're going to look at are some data relating average drive distance in yards and driving accuracy. Driving accuracy defined as the proportion of the drives that land in the fairway. And we're going to look at data from the top 10 money winners from the 2009 LPGA Tour. So, our first step is that we're going to make a scatter plot of the data. And you have been provided with this data in your notes, and also the graph for your scatter plot is already set up with the axes labeled and the scale already labeled for you. So all you have to do then is go through and plot a point. And remember, we're making a scatter plot. So that means that each of these pairs of numbers represents one point, where the first value is the x coordinate and the second value is the y coordinate, just like how you would plot them in algebra. So we'll go over to 246.8 and go up to the drive accuracy of 0.824, and we'll plot a point. So there would be that first point approximately. And because of the decimals, you can only be so accurate. So just do your best to kind of estimate where all those points would be located. And we get a graph that looks sort of like this. So there's all 10 points plotted. Part B is asking, what is the explanatory variable? Well, the explanatory variable is the x variable, and that would be average drive distance. And then the response variable is the y variable, which is drive accuracy. So, in other words, as a golfer, we can have some control over our drive distance by hitting the ball a little bit less hard or more hard, and that we want to see if that affects our drive accuracy. Now, in your notes, you have some steps for making a scatter plot on your calculator. And this is not required, but sometimes it's nice to just make a quick plot, and that will give us an idea of how the data is related very quickly without having to plot the points by hand. So you're going to enter the data into list 1 and list 2 into your calculator by hitting stat and edit, just like you've done with lists in the past. Once you have the data entered, you're going to access the stat plot menu, and that is above the y equals key at the very top of your calculator right under your screen. So you're going to hit second y equals. You want to choose plot number 1 and turn it on. And you can have there's a screenshot there in your notes of what that would look like. And then you're going to select the plot type. And notice when you select plot number 1 and you go into this menu, this option right here is the one that's going to give you a scatter plot. You want to be sure that you have your X list and Y list set at L1 and L2. The type of mark that you choose really doesn't matter. It's kind of just a personal preference there. Now you can hit the graph button, which is also right under your calculator screen over on the right-hand side. But you need to resize your window to fit your data. And the easiest way to do that is to hit the zoom button, which it says here in your notes. You're going to hit the zoom button, and then you're going to go down to option 9, which says zoom stat. And zoom stat is a really nice feature that will automatically resize your window to fit your data. So you don't have to try to worry about setting the X and the Y axis. It will just do it for you automatically. So you can go ahead and try that and make a scatter plot on your calculator and see what that looks like. All right, so now let's talk about the 3 things that we want to discuss when we're describing the association between 2 variables. The first one we mentioned was direction. And there are sort of 3 different situations which might happen. One is that you might have a positive association between your variables. And positive association means that as the values of X increase, the values of Y also increase. So they're changing in the same direction. A positive association would look something like that, where sort of like when you did slope and talked about rise over run in algebra, the values go up and then over to the right, and they would have a positive slope. Now, conversely, you might have a negative association, and a negative association means that as the values of X increase, the values of Y decrease. So X and Y are changing in opposite directions. Now, the last situation that you might notice is that you may have 2 variables with no association. No association means that knowing the values of one of the variables does not give us any useful information about the values of the other. So if X increases, we don't know whether Y will increase or decrease. And on a scatter plot, you might see something that looks like this, where you have just sort of a horizontal pattern or maybe some other kind of shape where you can't tell a direction very clearly. Now, in the golfing example that we were just looking at in example 2, they're asking you to describe the direction of the association in context. This clearly has a negative direction, which means that as the average drive distance increases, the driving accuracy decreases. So we would say that there's a negative association and that longer drives tend to be less accurate. Now, the second thing we want to discuss when we're describing the association between 2 variables is the form or the shape of the association. And there are a couple of options. One is that you may have a linear association. Linear refers to the fact that the pattern of the points can best be fit by a straight line. And they don't have to make a perfect straight line, but there should be a pretty clear linear pattern to your data. Now, the other situation is that you will have a nonlinear association, and that means that you will have some other shape that best fits your data. For example, we might have a curved shape like this, which you may recognize as being sort of an exponential growth shape that you learned about in Algebra 2. You may also have a situation where the values increase and then at some point turn around and start to decrease. That would be nonlinear. And this is sort of an exponential decay situation. All of those are curved, but rather than try to say it's exponential or it's quadratic, all we need to say there is that it is nonlinear, or you can say curved. Finally, the third thing we want to discuss when we're describing the association between 2 variables is the strength of the association. The strength of the association describes the amount of scatter there is from the overall form. So if you look at the 4 examples that are in your notes, notice that they're all given on the same scale, and they go from more or less to more scatter as we move from left to right. So the one on the far left-hand side would be considered a very strong linear relationship. It's not perfect, but it's pretty close. The second one would be considered a strong linear relationship. The third one we would say is still fairly strong because we can see a pretty clear pattern to it still, even though there's a decent amount of scatter. And the last one we would say is a weak relationship. And in this case, it is difficult to even identify it as a positive direction, just because there's so much scatter in that plot. Now let's go back and look at our golf example again. Example 3 says, describe the form and strength of the association between the drive distance and drive accuracy. I would say that this is a strong linear association. We already discussed that it has a negative direction, but it's pretty clearly linear, and I would say it's a pretty strong pattern there, so fairly strong linear association. In example 4, we're going to look at a new data set now. And this one says that the table shows the number of passing yards and points scored for each of the regular season games for the 2008 Detroit Lions. So now this time our data table is set up going horizontally. And when that's the case, the top row is typically going to be X and the bottom row is going to be Y. Unless you have reason to believe otherwise, that's probably the way that you're going to set them up. So in part A, where it says what's the explanatory variable, that would be passing yards. And then the response variable, of course, would be points scored. So we believe that if the Lions are able to get more passing yards, that would cause a change in the number of points scored. Part C is asking you to make a scatter plot on your calculator and then sketch it. You don't have to use the calculator to do that. You can also just sketch it by hand. But notice it says to include labels on the axes. When it asks you to include the labels, what we're looking for are the variables. So in this case, this is what the scatter plot would look like if you plotted it on your calculator. And we're going to label the explanatory variable, passing yards on the horizontal axis, and then points would be on the y-axis. Labeling with numbers isn't as important as labeling the variables. Now it says describe the direction of the association in context. These variables are clearly positively associated. So that means that the Lions tended to score more points in games when they passed more, which makes sense. Part E says to describe the form and the association. I would say that this one has a fairly strong linear association. And in another section in chapter 10, we'll talk about how to decide or how to quantify the strength of an association. But for now, we'll just sort of eyeball it and say that it's fairly strong. Please do homework 10.1 in your assignment packet.